today's lesson we'll be going over rotations. So we've already gone over like the rigid motion ones, right? We've gone over reflection, translation. Now today we're going over rotations. So with this one, right, rotations has a T in it. We've talked about reflection, which is a flip, or translation, which is a slide. Rotation itself, though, is a turn. Okay. So, I mean, it's exactly what it is. Y'all know what the word rotation is, right? If you have something here, you just kind of turn it around somewhere else, right? It's like a spin, right? So even if you move all this stuff. And again, for right now, for these notes, we'll just kind of go over through this, and we'll talk about the actual stuff in class and kind of fill out the rest of this. All right. But first, right, we have three different types of rotations we're looking at. We have a 90-degree rotation, a 180-degree rotation, and a 270-degree rotation. If again, you know anything about quadrants and like how shape is broken up or whatever, you know there's 360 degrees would be a full circle, and you can break that into four different parts, so it'd be 90 times or 90 degrees each time, right? So it'd be 90 plus another 90 is 180 plus 190 is 270. It all kind of works together because, right, if you look on a coordinate grid, and if you start on one point, right, 90 degrees would just be one direction. Another 90, another direction. All right, it'd be 180, so it'd be across, and then another 90, 270, so it'd end up here. 360 would be back here, which is why we don't really need it. And see, there's a blank space because that would be 360, but I mean, it's just the same exact thing. You don't have to do anything to it, so it's kind of pointless. You just know it's a full circle. All right. But either way, 90-degree counterclockwise rotation. So that's what's important too with rotations, right? There's two different types of spins you can make with this, right? Counterclockwise, which in this case, these are all going to be counterclockwise because these are the typical ones we kind of go through. If you remember anything about quadrants, right? This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So even as we're going around the quadrants, right, it's in a counterclockwise rotation because it's going the opposite way. So counterclockwise, just kind of remember what that is. In this case, right, counterclockwise, we've talked about before, and I'll just kind of rewrite it again. Counterclockwise is the spin that goes in this direction, right? The opposite way of a clock. That's why it's counterclockwise. Whereas clockwise, all right, clockwise goes the way a clock does, right? So you start here and you kind of go around this way, right? So again, different rotation, different rotationary spins. It's kind of hard to see those and zoom in on that. All right, yeah. All right. Anyway, let's talk about this. So counterclockwise. Okay. We'll talk about the differences of counterclockwise and clockwise in a little bit, but we'll get to that. So for now, let's actually talk about the rules. So, all right. So just as before, right, we've had x, y, that's our original point. And then how does it change? Like, what does it do to it? All right. So for a 90-degree counterclockwise rotation, what ends up happening is you're going to switch the x and the y as opposed to having an x here and a y here, right? You're going to have a y here and an x there, right? So whatever these numbers are, just change them. But then you change the sign of y. So switch these two and then change the sign of y. So first, right, and then the order you do it's super important, right? Because if you change the sign of, if you switch them, then change the sign of whatever the y, just trust me with this, right? The idea first, right? Switch the coordinates, and then change the sign of whatever your y was. I guess technically, yeah, that's fine. Change the sign of the original y. Okay. So in this case, right, we switch the coordinates and we change the sign of the y. So look out for that. Um, all right. So we're just going to continue following that path, follow that pattern, kind of do. For the 180 degree counterclockwise rotation, this one's actually pretty easy. It's kind of like one of the ones we've already done before. It's kind of like actually it's almost like a reflection, but you'll see what I mean in a little bit. So in this case, this one's pretty straightforward. All it is you just change the sign of both x and y. That's all you have to do. That's all we do is change the sign of your coordinates. All right. So yeah, I mean, just whatever they are, you just have to change the signs in. Whereas lastly, this one's very similar, right? There's a pattern to all these and how they kind of work out. This last one, it's going to be the same idea. You still now, right? You change the sign, or you change your x and y, but you change the sign of your x value, right? So this one is change. So change the sign of your x value. Ah, that's right. Okay, so I made a mistake up here, but really we're just gonna either way, just kind of flip these two. So this is actually gonna be second, and this is actually gonna be first. All right, so my bad, my mistake. Um, Make sure you do this part first. Change the sign of your y and then switch the coordinates. So I'm going to fix that on here, right? So first is change the sign of x, right? So again, the x has changed different signs. And then is switch the coordinates. It makes things a lot easier, right? So your original x, if it's a positive, change it to a negative, and then flip the coordinates. That's what that means. All right, so again, just be a mistake. Sorry about that. Make sure you know to change the sign of whatever you're doing first, and then switch the coordinates. All right. Um, that's going to be a lot more helpful. It's going to be a lot more useful. So again, take a look at that. Just be careful with that. But that's it, right? That's rotations. It's pretty straightforward. Again, just as long as you're kind of going through it. We'll talk a little bit more detail about what this looks like when we go through it in class. The last thing I kind of want to point out, though, just real quick, when talking about these are all counterclockwise rotations, as you can see, counterclockwise, counterclockwise, which is why we kind of did all this because it's a little bit easier, right? We talked about that. But also, if you're going to do, you can technically, if you turn something 90 degrees, if you turn like this 90 degrees one way, so now it's like sideways, go back to the original position. If you turn it 270 degrees the other way, so as opposed to going counterclockwise, so that's 90 right there, that's 180 clockwise, and then 270 counterclockwise. As you can see, it's again the position we had it where it's 90 degrees counterclockwise. So, just as something in case you have to know, 90 degrees counterclockwise is the same as 270 degrees clockwise. This one's the same no matter what you do. It's just a half spin. Whereas the 270 degrees is the same as 90 degrees clockwise. Just for you to help you out with that. All right. Okay. Um, yeah, that's really it. Oh, I guess we can kind of talk about the stuff over here. Yeah, let me fill in a little bit here. So rotation, right? So a little bit more info before we get to the actual examples and fill out the rest of this. A rotation. Um, Looking at this figure here, we have this point R, and it's this shape, right? This is our original shape. We're going up to here, right? And so what happens is, well, what's going on here, right? What's this distance? Well, how does it go from here to here? What's going on? Well, R is the point of rotation. Basically, where is this going to be spinning across, right? So like, is it like being, do we turn it from here all the way up here? No, you pull it from this point and then how much you're spinning it around that point, right? It's not spinning it from here and like shifting this way, right? That's not a rotation. This is a slide. But from here, how much it opens up, how much it turns, that's the point of rotation. The point of rotation is always going to be the origin unless specified otherwise. So really it's just going to be at 0, 0 for the most part. If we don't do that, it'll be a little bit more difficult, but don't worry about it. That's how it works. And then lastly, just real quick, we usually rotate in counterclockwise direction. And that's rotations.